Hello friends, welcome to ChemShastra. This is the third video on hybridization where we are going to discuss sp hybridization in more detail. So friends, you must have studied your alkyne chapter and in that you must have tried to find out hybridization state of carbon atom in your alkyne molecule. Now there's a one thing how you can remember hybridization, that is you can ratify the definition or you can ratify which molecule is going to have what kind of hybridization. But remember one thing friends, hybridization is not specific to the molecule, it is something which is specific to the atom. So it's always better that you should know how to find out hybridization instead of remembering or by hearting anything like alkyne is sp hybridized, alkene is sp2 hybridized and alkane is sp3 hybridized. And that's the reason why I have said in my first video on 10 concepts to master organic chemistry, you should know how to find out hybridization state for any damn molecule in organic chemistry. So let's begin friends. Few things I have kept same in this video as well, and that is the concept of hybridization if we'll talk about. So let's try to understand what is going to be the definition of your hybridization. Your definition of hybridization, if you'll ask me, is mixing of atomic orbitals, but this is a definition which is not going to fetch you the marks. So what is the actual definition you can remember for hybridization? It is the process of mixing and recasting of atomic orbitals of the same atom with slightly different energies to form equal number of new degenerate set of orbitals with maximum symmetry and definite orientation in space. So basically your hybridization for a particular atom tells you how that molecule is oriented in a three-dimensional orientation. So somehow that helps you to understand the organic reactions or organic mechanisms in more better way. Now this concept of hybridization was put forth by Linus Pauling in the year 1931. Now how to find out hybridization? So in this video we have taken a simple example, that is the ethyne molecule, and we are going to understand how we can find out hybridization of this particular marked carbon atom in ethyne molecule in a very simple, and I can say that in a very simple steps. Okay, so let's begin friends. This is how your ethyne molecule looks in a three-dimensional orientation where you are having 3 carbon-carbon triple bond. Okay, so what is the first step? The first step is you should know the atomic number of an atom for which you need to find out the hybridization. Now in this case your atom is carbon, so for which the atomic number is going to be 6. So its electronic configuration is going to be 1s2, 2s2, 2p2. Now if you are going to apply Abbo principle, Hounslow and Pauling principle, if you are going to fill up the electrons into the ground state of carbon, you are going to fill it like this. In 1s you are going to put 2 electrons, in 2s you are going to put 2 electrons, and in 2p you are going to put 2 electrons, okay, which are going to be unpaired in each orbital. Now if you know carbon is a tetravalent atom, that means carbon can form 4 bonds. To have that 4 bond formation or to have that tetravalency, carbon need to have 4 orbitals with unpaired electron, because any covalent bond forms by the equal sharing of electrons. So that's why carbon is a tetravalent. So what we are going to do, a very obvious choice we are left with is the excitation of electron, because when your carbon is in the ground state, you don't have orbitals, you don't have the 4 orbitals with unpaired electron, you have only 2 orbitals with unpaired electron, and that's why we are going for the excitation of electron. So I will excite 2s electron from carbon to 2p orbital of carbon, so that will give you another electron configuration. We are not doing anything to the 1s electron. Now remember one thing, 1s electron is the innermost electron which is the closest to the nucleus, and that's the reason why you cannot touch 1s electron, or it is also called as a non-bonding electron. So if you are going to excite one of the electron from 2s to 2p, your electronic configuration changes from 2s to 2p2 to 2s1 2p3. Now the first question, do you have 4 orbitals with unpaired electrons? Yes, now you have 4 orbitals with the unpaired electrons. So what is the next choice you are going to think of? Now 3 things that you need to remember for hybridization to find out hybridization state of any atom in any molecule. The first thing is you are going to include sigma bonding in your hybridization. So your hybridization you are going to include orbitals required for sigma bonding. So whatever number of sigma bonds you have, you should have that many number of orbitals with unpaired electron. Second thing what you do include is the lone pair of electron present on an atom. Now for carbon you don't have any lone pair of electron present on an atom, but if we'll find out the hybridization state of oxygen or nitrogen, then that will understand in a more better way. Now for carbon you need not to worry about that. Next one comes is you need to exclude pi bonding. This is a very important thing that you have to take into consideration. Now understand this, why do we exclude pi bonding in hybridization? Because the moment you go for the hybridization of your orbitals, you don't have any orbital which is going to be parallel to another hybridized orbital, and so that you cannot go for pi bond formation. And that's the reason to have pi bond formation you need to have orbitals which are parallel to each other. So make sure that you know how many pi bonds are there in that particular molecule. Now if you think of this carbon molecule, you know that there are 3 bonds, of which one is going to be always sigma bond and remaining 2 are going to be pi bonds. So how many sigma bonds this carbon has formed? This is the first carbon hydrogen sigma bond, and this is going to be the second carbon hydrogen sigma bond. So total number of sigma bonds are 2. So I will need 2 orbitals to combine. So I will take one s orbital and one p orbital. I will combine them, and that will give me sp hybridization. Now this last 2 p orbitals which I am going to have, I will keep it for pi bond formation. So for each pi bond you will require one p orbital with unpaired electron for pi bonding. Now this is going to be the electronic, this is something that I have given as extra information. Now the carbon is forming bond with hydrogen, for which the atomic number is 1, for which electronic configuration is going to be 1s1. So in 1s orbital, hydrogen is going to have 1 electron. So if you are going to focus on carbon in C2H2, that is your ethyne molecule, how it will look like. You are having 1s electron from carbon, don't worry about that. You have this 1 red electron from hydrogen atom, then you have this black electrons is from carbon atom, because the carbon is forming one bond with another carbon atom. This will give you sp hybridization, and remaining 2 orbitals py and pz I will keep for pi bond formation, in which each electron will be accepted from or shared with the neighboring carbon atom, and pi bond formation will happen in that case. So you are having sp hybridization followed by pi bonding. So you can keep any p orbital for pi bond formation. Your px, py, pz, all 3 p orbitals are degenerate. That means they are having same energy level. So you can mix up any p orbital and you can keep away 2 p orbitals for pi bond formation. Now let's try to understand how your sp hybridized orbitals are formed, or they are oriented in a 3-dimensional way. You are having one s orbital. Okay, so one s orbital. So 2s orbital you are having. So 2s orbital will combine with your 2px orbital, and that will give you what is known as your sp hybridized orbital. Now if you do know, if there are 2 orbitals which are going to combine, so first thing to remember, if you are going to have 2 points in a plane, only geometry what you can draw is a line. If you are going to think of line, a line divides circle into 2 equal parts. So circle is having angle of 360 degrees, so you can remember it that way, 360 by 2, which is going to be equal to 180 degrees. So for any sp hybridized carbon, your bond angle will be 180 degree. Next thing is the formation of ethyne molecule. How the orbital overlap happens? A pretty simple job. You are having one carbon which is sp hybridized with the overlaps with the one hydrogen atom. Then you have another carbon with sp hybridization overlaps with another hydrogen atom. Now this red what you can see over here, in this case, is the one which will give you a bond, pi bond formation. So the red orbital helps in pi bond overlap, and you get a pi bond formation over here. So these are the things. This will overlap with this one, which is a lateral. They are parallel to each other, will do one pi bond formation, and you can see over here you have another orbital which is parallel to each other. So this will give you another pi bond formation, and that will result into formation of a very simple molecule, basic alkyne molecule, that is ethyne molecule. Okay, and now this was all about the sp hybridization, friends. Thanks for watching this video. I hope you are liking the way I am giving you the explanation on hybridization, or the concept that you need to know the organic chemistry very well. If you have any question for that matter, you can please put it in the comment box. I will make sure that I will make video on that, and that concept will be justified or explained in the as simple as way possible. Thanks for watching, and do subscribe to our channel ChemShastra, and you will enjoy the very beautiful content which is going to come up next in the next videos. Thanks for watching.